In this video, I'm going to show you how you can write balanced redox equations using half equations for reactions. In my example, during a reaction between sulfur dioxide and acidified potassium dichromate, the sulfur dioxide is oxidized to sulfate 6 ions and the dichromate ions are reduced to chromium 3. Write a balanced overall equation. Well, the first step always is to write your two half equations, one for the oxidation reaction and one for reduction. So let's start with oxidation. I have got sulfur dioxide being converted to sulfate 6 ions using oxidation states and changes in oxidation states. I can see how many electrons I have lost. Each sulfur in this case will have lost 2 electrons to move from +4 to +6. I need to balance out the oxygens by adding water, so +2 H2O, and I balance out the hydrogen I've added with hydrogen ions, so that would be +4 H+. If I've gone too fast through that, then flip back to the previous video where I went in detail about how to balance half equations in acidic and alkaline conditions. So that's my first half equation. My second half equation, I have got dichromate ions, so Cr2O7, 2-. You can see here that we've automatically got rid of the spectator ions, which in this case was potassium. And they're being converted to chromium 3. I've got 2 chromiums in my dichromate ion, so that would be 2 Cr3+. The oxidation state of each chromium in the dichromate ion is +6, going to +3. So each chromium atom has gained 3 electrons. So I need to write +6E-, because I've got 2 chromium atoms, on the left-hand side. Next step is to balance out the oxygens. So O7 means I need 7 water, and 7 water means 14 H+. I could just about squeeze that in. I know that this is under acidic conditions in both cases because it said acidified potassium dichromate, and writing half equations and balancing redox equations is nearly always under acidic conditions at A level. So in order to write this as a balanced overall equation, I need my electrons to cancel out when I add my 2 equations together. So I need to multiply my first half equation by 3. And then I can write my overall equation. So what does that look like? It is going to look like 3 SO2 plus 2 3s are 6, 6 H2O, and then going down to the second half equation plus my Cr2O7, 2-, my dichromate ion, plus 14 H+. The electrons are going to cancel out, so that is going to form 3 SO4, 2-, plus, how many waters have I got there? 3 4s are 12, 12H+, plus 2 Cr3+, plus 7 H2O. My electrons have already cancelled out. The last step is to cancel out water and hydrogen ions. So 6 H2O versus 7 H2O, so they are going to disappear. And that is going to become 1 H2O. 14 H+ versus 12 H+, well, the 12 H+ there are going to vanish, and my 14 H+ is going to become 2 H+. And then I can write out my final equation. It is going to look like this: 3SO2 plus Cr2O7, 2-, plus 2H+ goes to form 3 sulfate 6 plus 2 chromium plus water. And because this is a balanced equation, I would add state symbols at this point. It's an aqueous solution, which makes life very simple because everything is going to be AQ, except of course water, which is a liquid. Done. If this has been useful, hit the subscribe button, the effortless way to support your studies. And by clicking the link in the description below, it'll take you straight to Crunch Chemistry School, where you can access my free math skills course, complete tuition, and worksheets designed specifically to build your confidence and stretch you. Together we can do this.